Okay. What we're doing today is this is the second day of conic sections. And what I want to look at is comparing two. So we're going to compare this one, x minus 1 squared over 9 plus y plus 4 squared over 25 equals 1. Okay, and we're going to compare that to the same equation, but with a minus. Now, which one is the one we were doing yesterday? Can you tell? Or 2 days ago? Do you remember which one it was? Did the circle have a plus or did the circle have a minus in the middle? So flip to your notes yesterday. Did the circle in the ellipse have the plus in the middle or the minus in the middle? Anyone remember? Okay, so the plus means it's an ellipse. And the minus is going to mean it's a hyperbola. And we didn't do that one yesterday or 2 days ago. Hyperbola. So an ellipse is like a circle. And a hyperbola kind of looks like two parabolas. Okay, so what we did before on the ellipse is we found the center, and then we found the x radius, and we found the y radius. Now you'll hear me saying a lot for centers and any of these conic sections is you have to make sure x is with x and y is with y. So for the ellipse, you do opposite, opposite. Okay, so that would be 1, -4. And the reason you put the 1 in the x spot is the reason you put it in the first spot is because it said x minus 1. If for some reason that said y minus 1, then you have to put that 1 in the y spot. Okay, and then this is the same thing. This is the y, so you have to put it in the y spot. We're going to see that with example 3, that's going to be a little different for hyperbolas. Okay. And then to find the x radius, you're going to take the square root of what's under the x. Okay, so what's under the x? And sometimes the x is second in hyperbolas. So you're going to take the square root of what's underneath the x. So in this one, that would be 3. So the y radius, you're going to take the square root of the 25, and that's 5. And this 1 must be 1 in an ellipse. So we're going to see how we can change things into these formats. And when we change things into the formats, we'll have to get a 1 there. Now, in the hyperbola, we're going to actually do the same thing to start with. So you're going to say, what's my center? What's my x radius? What's my y radius? And you'll see that this is the same problem. So this is opposite, opposite. Now, with the hyperbolas, you have to be careful because sometimes the y is first. In this case, the x is still first. So when you do opposite of the 1, you put it in the x position. When you do opposite of the +4, you put -4 in the y position. And then the x radius, you take the square root of what's under the x, and the y radius, you take the square root of what's under the y. So we get exactly the same thing with the ellipse and with the hyperbola. So the ellipse and the hyperbola at the moment look the same. So you have to memorize what the plus and the minus mean. Okay, so we're going to graph the ellipse first. The ellipse needs less space than the hyperbola. And then let me know if I'm going too fast or too slow. Sometimes I might be going too fast. So this is 1, 1, 2, 3, 4. And that's where your center is. And then usually next to the 3, do you see the x radius at 3? I usually write left and right arrows. That helps later when you're trying to write equations. And then for the 5, I do up and down arrows. So the y always goes in an up and down direction, and the x always goes in a left and right direction. So let me move up a little bit. Okay. So x radius is 3, so that means you go to the right 3 and put a dot. This is the center. You go to the left 3 and you put a dot. You go up 5, 1, 2, 3, 4, 5, and you put a dot. And then you go down 5, 1, 2, 3, 4, 5, and you put a dot. And then you do the same thing for hyperbolas. So exactly what we did there is going to be the same, and then I'll show you where they're different. So 1, -4. You do to the right 3. Oops, I put that in the wrong spot. I forgot I didn't actually put my, oops, let's put that back. I'm just trying to erase the dot because the dot wasn't supposed to be on the axis. Okay, so it was 1, -4. That's right. And then I went to the right 3, to the left 3, up 5, and down 5. So far they look the same. Now for the ellipse, you make it look like kind of like a football. Don't make it too pointy. So that's what your ellipse looks like. And let's write ellipse on it so you could remember that that shape is an ellipse. Okay, and then I want you guys to let me know when you're done up to where I am. Okay, because the hyperbola is kind of strange. So if I graph too fast, then you're going to get confused by the hyperbola. So you let me know when you're ready, okay? Okay, so what about the rest of you? So I have Alyssa and Jacqueline ready. Becky and Carrie, how are you guys doing? Oh, it looks like Leon must. Okay. Carrie, are you good or are you multitasking? Ready. Cool. Okay. So, okay, so what you're going to do on this one, so the ellipse is done. Okay, so what you do on the hyperbola is, and I'm going to draw it actually on the ellipse. I'm going to erase it in a minute, so just look at this, okay? So what you do is you make a rectangle. So don't draw this on the ellipse, just take a look at it. But basically you draw a rectangle kind of protecting the ellipse. Okay, and then that one I made it too far. So you make a rectangle with those endpoints, those dots that you made. So this one went a little too far. Okay, so my hyperbola is going to be based on this box. Now you don't draw the box on the ellipse because the box doesn't have anything to do with the ellipse. But what you're going to do on the right one is you're going to make a box, and usually people draw it dashed. Okay, so you're going to make a rectangle. You're going to make a rectangle connecting those dots. But it's kind of weird because it's not the corner of the rectangle, it's the middle edge of the rectangle. So it's the box that surrounds the ellipse if you were, going to make an ellipse. But I'm not making an ellipse because I'm trying to make a hyperbola. Okay, so usually you don't actually draw the ellipse on it. Yeah, that's pretty much impossible to erase that highlighted part. I guess that's good enough. Okay. Okay, so how are we on the box? We good? Okay, so now what you're going to do to the box, now the ellipse lives inside the box. So the hyperbola lives outside the box. So the most important part of the hyperbola is the outside of the box part. So what I do is I start from the center, except I'm on the eraser. Okay, so I start from the center and I draw a dashed line through the corners. And the important part of this, it's called an asymptote, but the important part of this is the part that passes. So the part that's inside is where the ellipse lives. So it's not as important. So you have to make sure that you draw these asymptotes past the box. Okay, and then usually I start from the center and I just keep going until my paper ends. Okay, but you want to make them kind of long because the asymptotes, these lines that I'm drawing right here, these are the structure of the hyperbola. How are we doing so far? So let me know when you're here, and then I'll tell you how we do the rest. So we haven't actually drawn the hyperbola yet. We're just doing the structure of it. So let me know when you get to where I am. Perfect. Okay, so what we're going to do next is there's two different types of hyperbolas. So don't draw either one of these in yet. Okay, so, and we're not going to draw them with highlighter. So don't draw the highlighter. But what you're going to do is it could be a hyperbola that looks like this, but don't draw it in yet because I want to show you the two types. So either you have this yellow one and then the same thing over here, and it goes close to the asymptotes, or you have one that goes in this part and then in this part. And the hyperbolas never go inside the box because that's where the ellipse would live. So we have to decide by the equation whether we're getting a left-right, which is the yellow, or an up-down, which is the blue. So we have to know from the equation. Okay, so how we're going to tell is we're going to tell which letter is positive or which letter's first. I sometimes don't like to call it which letter's positive because I don't mean the insides. See this minus sign here? Okay, the minus sign is in front of the y. I want the positive term. I don't want the one after the minus sign. Okay, except I highlighted it maybe in the wrong color. So the first one here is a yellow. Okay, so the first one here is X. So we're going to write a note. I'm going to change colors. Okay, I'll draw a little note over here. I'm going to put the first term is X, and X is L/R. So that means left and right. So the shape that we're going to have is the yellow one. Okay, so draw the yellow one in your pencil. So the yellow one is actually the hyperbola itself. Okay, I'm going to also draw it in blue. Okay, so this right here is the hyperbola. And you're supposed to, it's not like a parabola because parabolas don't have asymptotes. So it kind of looks like a parabola, except you have to be heading towards the asymptotes. You do not want it to look like this blue one, because that looks like you're not going towards the asymptotes. So the blue one is not a good one. Okay, and the reason you're having it go left and right is because the X was first in the equation. And then let me label this dot right here is called the vertex. And this dot right here is called the vertex. Which makes sense from the parabola point of view. I have to give you just one term on the ellipse so that you can tell what the vertexes are. So in an ellipse, so I'm drawing this on the left side, they have something called the major axis, and you have something called the minor axis. And I think of the major axis as the longer diameter, and the minor axis as the shorter diameter. Nobody really calls it a diameter in math, but to me it makes sense because, you know, the diameter goes all the way across the circle, so that's what the major axis means. So the vertices of an ellipse, so vertices of an ellipse, and we'll talk more about this on Tuesday next week. The vertices of an ellipse are on the major axis. So they're on the longer one. So in this one, the longer one, oh, that could be where my yellow highlight that I couldn't erase could be. So the longer one is the up and down one in this problem. So these two are the vertices. So this is called the vertex, and this is called the vertex. So there's two vertices on ellipses. And then the ones that are on the shorter axis aren't called anything. And then sometimes on next week on Tuesday, they're going to ask you, what's the length of the major axis? What's the length of the minor axis? And so you can kind of count on your picture, you know, how far was that? The length of my major axis, I think I went 5 up and 5 down. So the length of my major axis would be 10. And then the length of my minor axis would be 6 because I went left and right 6. And then they don't use those terms for hyperbolas. They use other terms, but not those. Okay. Questions so far on what we've done? No. Okay. Okay. Okay, so what I want to show you next, and these examples are very linked, okay? So example 1 is an ellipse. Example 2 is a hyperbola, but this hyperbola is a left-right hyperbola. Maybe I'll put that right next to the name. So this is a left-right hyperbola. So what we need now is we need an up-down hyperbola. Okay, so we're going to make an up-down hyperbola. So I'm going to scroll down to get to the other part. Okay. So example 3, and this would be the one that if you do conic sections in a class in college, you're going to want to make sure that this example 3 is one that you would study before the test, because this is the weirdest one. Okay, so this one, let's have the same, but I'm going to put y first. So y minus 1 squared over 9. Minus has to be a minus or it's not a hyperbola. Okay, so it has to be a minus in the middle. And then x plus 4. So we're going to say what happens if the x's and the y's were in a different position? Equals 1. So I believe that's the same thing. Yeah. But I just changed x and y. So when you find the center, you still do opposite, opposite. But this one's really, really tricky. So let's put 3 stars by the center so that in case you ever have to study for a test on this material, that you remember this is the part that you have to study and be careful with. So when you do the opposite, oh, I have something on my computer screen. I thought it was on video. Okay, so for this one, I do the opposite. Now, this is xy. So when I do the opposite of y, which would be 1, I have to put that in the y spot instead. And when I do the opposite of the x, I have to put that in the x spot. That's kind of odd because we're so used to just picking the first number and then the second number in order. But so that's when I say x with x, y with y. So you'll hear me say that a lot. So x with x, y with y. So if I want the x value of the radius and the y value of the radius, it's like the radius of that box. Not really the radius of the shape, but it's the radius of the box. I take the square root, but for x radius, what's the number underneath the x term? So can you type in the answer of what's underneath the x term? What number is underneath the x term? Exactly. So the 25 is under the x term. So that's the x radius, and x is always left and right. And then for the y radius, that's the square root of what's under the y term. And then that's up and down. So your box is going to be in a different position. And then also when you draw those, you know, the highlighted branches in, the yellows or the blues that I was showing you, whether it's an up-down hyperbola or a left-right hyperbola will be different too. So I'm going to circle this right here and draw a little arrow. Since y is first, and y is an up-down thing, then it's an up and down hyperbola. So an up and down hyperbola is going to be like this once I draw the picture. Okay, so let's draw the picture. So -4, 1. X radius is 5, so go to the right 5, go to the left 5, 3 up, 3 down. And then you have to be real careful not to draw an ellipse because every time I draw that, it looks so like it's so ready to just draw an ellipse in. But the negative here in the middle is what makes it a hyperbola. The negative makes that a hyperbola. Circles and ellipses have a plus. Okay, and then you're going to draw a dashed box connecting those ellipse dots. So you're going to draw a box. And then you're going to draw the asymptotes. And remember, the part inside the box is not as important as the outside. So everybody always draws their asymptotes too short. So you want your asymptotes longer than you would think you would. Okay, so tell me when you get there. And then we'll finish it up. Okay, so since y is first, it's going to be an up-down hyperbola. So this is your vertex, and then try not to go in the box. Okay, so try not to go in the box, and you're kind of going towards the line. I'm going to draw it with the blue line here. So I'm going to draw it with my regular blue line. But you're basically trying to make a parabola that approaches these asymptotes. Okay, so they kind of look like parabolas, but they approach the asymptotes. The most common thing to do is to kind of go back in the ellipse box. So you have to focus on staying away from that. And I do find that the longer I make my asymptotes, the easier it is to draw. So this would be how you graph the hyperbola. Okay. And then I want to show you one more example. It's called completing the square. To write a circle's equation in standard form. Oh, except, sorry, the 8x is really an 8y. And then I'm going to teach you how to do it where the why you know this is a circle, but I'm going to show you that another day. Okay, so what the steps are to do this is you're going to organize the x's and the y's, and then you put the number on the right side. Okay, so what you do is you put the x's together, but leave a space. You put the y's together, and you leave a space. And then you move the 24 to the other side. So how do I move the 24 to the other side? Yes. So I'm going to add the 24 to the other side. Okay, then you're going to complete the square. Okay, so I'm going to call it CTS. Okay, but it's really called complete the square. So I'm going to write complete the square also. But you really want your brain to see the CTS, complete the square. For the x's and the y's. Now, do you remember the formula for completing the square? There was a half in it. Anyone remember what that formula was? Oh, I just put the squared at the end. Oops. But half of what? Do you remember what we took half of? It was first semester. It was a long time ago. Yes, it's half of B. I call it half of the middle term, but what Jacqueline said is right. Okay, so it's half of the middle number squared. And by the middle number, we mean the 6 and the 8. So what you're going to do for this one, so let's draw an arrow. You're going to do half of 6 squared, 3 squared, 9. And then for this one, let's draw an arrow from this one up here. You're going to do half of -8 squared, which is -4 squared, which is 16. And then I'm changing color. So if you have another color, that's better. Okay, so back under step 2, I'm going to write another thing, but I'm going to write it in red. You're going to add to each side. So I'm going to put a +9 after the 6, and then I'm going to also put the +9 on the right side. That's why I'm using another color. And then I'm going to put a +16. I'll change colors here. I'm going to use a +16. You could do it in red also. Put a +16 and then put a +16 on this side. So you have to match them up. So whatever you put on the left side, you have to also put on the right side. And then step 3 is you're going to factor four. You're going to write like this. And then that's actually the end. It'll be in circle form when we finish this one. So for this one, I'm going to factor. And this one, I'm going to factor. And this side, we might as well add. So that's 49. So x squared plus 6x plus 9. How does that factor? Anyone know how that factors? How does that factor? It does. It factors to 3 and 3. So that would be x plus 3, x plus 3. And then this one is y minus 4, y minus 4. There was a shortcut we learned, which is that this plus 3 is really this 3. And this minus 4 is really this minus 4. But I only use that shortcut if there's fractions. You'll see those blues and those yellows. So I usually just factor it the way I know it factors. And then it says write it like this. And then this is okay for a circle. So on next week on Tuesday, I'll do them with ellipses and hyperbolas, and that's supposed to be a 1. So we have to divide to get rid of it. But this is okay for circles. So circles, you're allowed to have a number there. Okay, so center is opposite, opposite. So -3, 4, x with x, y with y. And does anyone remember what we did with the circles with the 49? What else do we need to graph a circle? I'll procrastinate by drawing my center here. What else do I need in a circle? It's not really the x radius and the y radius. It's the official name. So we have circles, and circles have centers, and circles also have, what's the word? What's the other word, or what letter? Anyone know? It's the square root of 49. But what do I use it for? Anyone remember?
What's halfway across the circle called? What's halfway across the circle called?
No, that's good. That's a parabola, but not a circle. So halfway across the circle is R. What's R stand for? Yeah, radius. Yeah, radius. Okay, so from here you go 1, 2, 3, 4, 5, 6, 7 to the right, to the left. 1, 2, 3, 4, 5, 6, 7 up. 1, 2, 3, 4, 5, 6, 7 to the right. 1, 2, 3, 4, 5, 6, 7 down, and then you try to make it look circular. And that's it. The end.